What are joint, marginal and conditional probabilities? In this video, we will try to understand that. Let's say there are two random variables x and y. X can take any of the values x1, x2 to xn and y can take any of the values y1, y2 to yn. Let's say we are interested in knowing the probability of two simultaneous events. In other words, we want to know probability x is equal to xi and y is equal to yj, where both I and j can take values from 1 to n. Such probability of two simultaneous events is called joint probability. Let's look at an example. Let's say we roll two fair dice. Let's also assume that capital X denotes the outcome of the first die and capital Y denotes the outcome of the second die. Now, there are total 36 possible outcomes, and as both dice are fair, each of the outcomes is equally likely. In other words, the probability of each outcome is 1 by 36. So, the joint probability distribution of x and y can be given by the following table. So, if we want to find out the probability p x is equal to 2 and y is equal to 3, we can do so easily using the joint probability distribution table of x and y. Now, let's say we want to find out the probability that the first die will have an outcome of 3 irrespective of the outcome of the second die. In order to find the probability from the given table, we need to add all the numbers in the third row, and that will give us 1 by 6. In other words, the probability that the outcome of the first die will be 3 irrespective of the outcome of the second die is summation from I is equal to 1 to 6, probability x is equal to 3, y is equal to I, and after calculation this is 1 by 6. This probability of the outcome of one random variable irrespective of the outcome of another random variable is called marginal probability. This is called marginal probability because the values of the marginal probabilities we write in the margin of the joint probability distribution table. So, in our case, the marginal probability distribution table of x and y can be given by the following table, and the conditional probability is the probability of one event given the occurrence of another event. We write it as probability A given B, and probability A given B is equal to probability A and B divided by probability B. Let's look at an example. Let's say we roll two fair dice like before. The random variable capital X denotes the sum of the outcomes of both the dice, and the random variable capital Y denotes the outcome of the first die. Now, we roll both the dice and see the outcome of the first die is 3. At this point, we want to know the probability of the sum of outcomes of both the dice being 6. In other words, we want to know Px given y, where x is sum of the outcomes of both the dice and y is the outcome of the first die. Here, y is equal to 3. So, there are 6 possible outcomes. So, the probability that the sum of the outcomes of both the die is 6 given the outcome of the first die is 3 is probability of getting 3, and that is 1 by 6. I hope this helps. Interested viewers who want to know more, please refer to the playlist Statistics for Machine Learning or visit the website of the Security Buddy. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.